Hello everybody, have a good day. We shall start now with the design of multi-storied building frame. We have last class module we have discussed general idea of how to choose beams, columns, slabs, footings, staircases, other things in general that now we would like to use it for a building we shall consider. So, this particular one whenever we are considering here, so we shall take a G plus 3 storied school building that we shall consider, and whatever we have discussed already, and as we all know it may not be clear how to apply these design methods to a full structure. So, we shall take one example of a frame structures and we shall take a G plus 3 story school building that we shall consider, and that is very common because that is a and so simple also that particular one, and as you all know in classrooms always simple problems are solved, the difficult problems are kept for the students. So, anyway, so coming to that particular one here, that this particular building. So, first question is coming here that how shall we decide that school building that we require. So, school building, just to give you idea, let us consider the school building and the school having, we require how many classes we require, that is number 1. So, let us say that we are having class 1 to 5. So, 5 into 2 sections in primary sections in a particular class, that means we require 10 classrooms. Then class 6 to 10, again we are having 5 classes into we are putting here 3 sections. So, we require 15 classrooms because primary section whatever in a particular class we have, in secondary, this one if we say primary, then we are having secondary and then higher secondary. I am not going to this one because let us start from the very beginning instead of giving just a one small problem. So, class 11 and 12. This one we are having that science we can have with maths, biology or computer science, like that we can have. Then we are having arts and then we are having commerce. So, we can have here 1, 2, 3. So, 1, 1, 1, 1, 1. So, 5. So, 5 into 2 we are having 10 classrooms for this high school. In addition, we require laboratory for physics, chemistry, biology, computer lab, maybe 2 numbers, one for the senior, one for the junior, sports room for indoor and outdoor for storage. Whatever we are having outdoor, that equipments, all those things that should store. Then we are having music room, washrooms, at least two, one for boys, another for girls, and one for teachers also. So, 3 minimum. Then we are having office, teachers room, and principal's room finally. So, you have to give space for all of them. So, this is your 10 plus 15 plus 10. So, we are having here 10, 15, 10, then we are having here 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 2, 15 minimum, we require 50 minimum, that classroom is equal. What is the size? That is your another question. The size, that is also another question that we have to decide, that what will be the size of that room, that also we have to decide. Now, here this particular one here, I have not told you that one, your say another important part, that is your say staircase. The next one, whatever we shall decide, that what will be the layout of the building. We can think many ways. There are many schools also, you can compare with your school also, such a beautiful school you have. So, but I would like to say, because as I have told you that I would like to make a simple problem, and then what we can do it here, we can make the school like this. We can have this way, we can have here, sorry, I have made little bigger, anyway no problem. This portion we have actually your for staircase, and then again we are having this side, we are having another such one, we can make it. So, this is the one we consider that particular building, we can make like that, and we shall utilize that at certain gap like this. It will come in this fashion, it will go, it will come in this fashion, that classroom I mean to say. Now, what will be the size? Generally, the rule says that classroom should be made for 40 students, and for that we need 7 meter by 7 meter. So, this is your that 7 meter by 7 meter that we need. So, this is one classroom size, and we shall keep it everything in multiple of that. That means, whatever we have discussed now, that all the classrooms, all of them will have that particular 7 by 7 meter. That is the one clear space, that in between we should not have any column. That is the one classroom that we should have, and then on the basis of that we shall decide that how shall we consider that. So, here the school building, we are taking only one part of it that we shall consider, and that we shall find out here, that we shall consider beams and slabs and columns, that how shall we design all those things that we can find out. I am sorry, this is figure 1 and figure 2. So, which may come in this fashion. I shall come back to that particular one here, that one we shall come back. So, this is the one that your frame it will come. So, let me show you that a frame. Only I would like to say, just to give you idea that whatever we have discussed, this particular module say we are considering the staircase module, that is another one, that particular one. If we consider at this point, you will find out there is one column here and side by side another column also here. Only they are having that common footing. So, we can consider this block separately, this block separately, this one also we can design separately instead of putting them all together. So, I shall show you that how to make this particular one. Let me show you here. So, what I require, that I have certain axis, red, green and blue. Red means x axis is along x axis, green along y axis and blue along z axis. So, you can see that particular one, why I am telling this particular z axis here I am talking. So, this particular point actually pointing towards you, that is the one, please note this particular, not the other way, not going inside the screen, it is coming out of the screen. This is very, very important when we shall do the frame, that analysis for that particular one we require. Obviously, we require a site, that how much site we require, as we have noted down this particular one here, that you are require 7 meter, that particular one here noted down. So, let me show you a figure. So, this is the one we are having. So, as you can see, so we can find out here. So, this x axis here, y axis and z axis, this is the one your plot or site where you have to construct your that school building. So, that is the one we are having. So, now first thing we require the grid point, because I am just showing this one, that construction, and then I shall show you the different aspects we shall show you. So, let us go that as if you know everything, that particular one it has come and I would like to construct that one. So, first thing we have to do, that we have to give the grid points. So, you can see this grid point. So, these are the grid points, that means here we shall place the columns at different points. So, that we have to fix it on the ground, that is the one. We have to make that particular one grid point, that we have to make it here, that we have to find out that at different points we shall make it here, because at this point we shall excavate and then we shall start doing the foundation. That is the first thing we shall do it here. So, we are having footings first, let us make it, just see from the bottom. So, we are having these footings for each column, whatever we are having, and this one to be decided by the shape bearing capacity of soil, that is the one it will be decided, so that it does not pierce through the soil ground. So, this is the one we are having, that your say footing that we are having, and below that we are having here. So, that particular one we can have. Next one we are having columns. And then we are having beams, column at the ground floor then we are having beams, next we are having the deck, first floor deck that we are having here, first floor deck that we can have, that we can find out here, that particular one we can have. And then over that we shall have column at first floor, then we are having beams, then over that deck. Though I am showing this one just for your convenience, actually your beam and slab actually cast together. It is not the one first will be beam will be cast and slab not. Just to give you, just to identify that one I have shown like that, so that you can distinguish. Then you are having the next floor level columns. We are getting that all the columns that to be constructed up to the soffit of the beam, because beam that your beam and slab that one will be made together. So, we have got this particular one here. So, this slab, again the next level of columns, beams, another level, finally at the roof level that deck. So, this is your that complete thing that we are having here, that particular one that we can have. So, I can see this one here, let us consider that particular one. So, that means these points are grid actually made, and on the basis of that we can find out. So, coming to this one here, let us make it here. So, this is your grid point A1 and this is your that slab, a slab panel that we are having here. What we have done basically here, this particular one we can consider, just remove that. So, this block we can consider here that we are having. So, I have taken this one as 3.5 meter each, this one I have made 7 meter, and then we are having this corridor like that we are having. So, what we are basically doing here, just let me give you idea that what exactly I am doing, that particular one, just let me give you, so that it will be clear that. So, here what we are doing basically here, this is your that grid, whatever we have done, we are having this L1, L2 and L3, A, B, C, D, E, F, G, H, I. So, we can consider that one here as this is one classroom, another classroom, this is another classroom, and then we are having this is another one. So, we can have 4 classrooms in each side. Four classrooms we can have in each side. So, G plus 3 means 4, and we are having 1, 2, 3, 4, 5, 6, 7, 8. That means I can have 4 into 8, so 32. So, we can have this one 4 into 8, 32 we can have. We can make like that, we can make another one, we can make it. So, that we can go up to 64 also we can go. So, all the things we can make it. We can give actually toilet that we have given, washroom we have given only one each. We can give it to in each floor also we can give, and that way we can go up to 64 for future provision, other things that we can consider. Music room, maybe we can have 2 also, different kinds of music room, modern, then classical, like that. So, there are so many other utilities for a school. Actually, you are having many more things for a modern school we are having. So, our objective here, whatever I have shown here, this particular one here. Now, let us just go back again, that we shall at least we shall know. So, then we shall come back. So, coming to this one here, again we have started, just let me give you here. So, this is the one first floor level here, and we have to provide the deck. So, the deck we have provided, this is on the first floor level, that what go on here. The question is coming here, how shall we place the columns and how shall we design it? That first we require that you say moments, we require that moments that we require. What we shall do, this particular one, let us make it. These are the columns we are and beams we are having. So, whatever we can have, we shall design these frames, each frame we shall design. So, we are having this frame we are having, there is a gap actually there, somehow other it was made, that gap should not be there, this is continuous, that particular one here. So, whatever we should have this particular one here, these are the frames, that plane frames we have we shall take, that particular one we shall take. Now, question is that why we have taken this one, these frames we shall take it, why not the other one? I mean to say that I could take the other one also, just let me show you. So, the frame can be like this also, because why not this frame, why the other frame we are considering here, that means this particular one why you are considering. If you see that to lateral bending, other things for the whole building, if you see, just let me give the roof part only, this particular building if you see, the thing is that your one is that BD cube by 12 that you can consider. So, BD cube by 12 that we will consider here, and that will be decided. One will be that BD cube by 12 if you really consider that particular one. So, we can find out this section. So, this is B and this is D. So, what we shall consider here BD cube by 12, that we shall consider here. So, when we consider that BD cube by 12, or it could be DB cube by 12. So, this one will be smaller. So, your column placement also should be such that your column placement also will be like this. Rectangular columns, whatever we shall place in this fashion, not the other way, like this, because it is very easy to bend in this fashion, not in this way. So, that is why we make this one in this fashion that we make it. So, your shorter direction will be in this direction, this will be your B and this one will be your D. So, like that. So, we can have in this fashion, we shall go that way, we shall make it in this fashion, we shall make for all of them, and we shall do the plane frame analysis that we shall do it. So, we shall do the plane frame analysis that we shall do it. So, just to make it clear. So, that means if you come to this one here, we have to do that means we shall solve, if we can solve say any one of them, either this is one because it is will be less loaded, and in between you are having another one that is another loaded that we can consider, and on the basis of that we shall decide that how many columns, that means that we shall come on the during frame analysis. So, that means we can do the plane frame analysis that we can do it. So, we can do the plane frame analysis here. So, we shall not solve this one here, rather we solve these beams, other things we solve it on the basis of your other part of the section. We use this formula just to give you idea, that is your say table 12, we use table 12. So, table 12 we use it for from IS 456. So, table 12 and 13, this is for bending moment, and this is for shear force. So, we shall these coefficients we shall use it to solve this. So, that means this one, these beams only for stability purpose we shall use it. So, coming to that one here, whatever we shall do it, just remove that for the time being. Let us go back to that section again. So, I shall make it here. So, if we take any one of the section, so this column, this frame we shall consider plane frame, we shall consider this frame because this will be the shorter direction. So, that is why we shall consider here like this, and we shall not consider only load of the slab, we shall consider the structural strength of slab, we shall not consider during frame analysis. That means, we are in the conservative side. So, that means, if we can solve only two frames, one outer one, another one intermediate one, that will be sufficient for our design. And then this side we shall consider the beams, whatever we are having this side, that beam we shall consider this type of beam that we shall consider here, for individually we shall design, and that we shall design as per your say table 12 and 13 of IS 456. That is the one we consider here. So, this is the general philosophy how we consider that you can do it by any other commercial software, you can use it, and for that you can find out the bending moment shear force. But my main objective here just to show you that how you yourself can do it on your own, that step by step you can do and you can find out. It is not a miracle, you can go step by step, you can find out, and this is the one that we can do it. So, we shall now come back to the detail of that your say earthquake analysis in the next module. Thank you very much.